Hi and welcome to Time for Bikes. So in today's episode we're going to start looking at how we're going to actually change a really nice old iconic 26-inch wheel mountain bike frame into something that is capable of being an amazing gravel crunching machine. Now there are lots of things we're going to do to this, but you guys are going to be with me all the way through this, hopefully from start to finish. It's going to be spaced over a few episodes, but mainly we are going to be using old parts, new parts, probably more new parts as the build gets more complicated and we learn more about how this whole bike can go together. But by the end I'm hoping to have a really nice gravel machine to use that will have bigger wheels, a more modern drivetrain, newer, nicer brakes if we can possibly do that. And also we're going to have to change the cockpit quite a lot because obviously normal mountain bikes back in the day of the 26-inch wheel were just quite, well, short, straight handlebars that we really not going to be using. We want the drop handlebars, and also we just want this to work. We want this bike to work really well. There are a few problems that I already know about, but I think that's it. I think we're just gonna have to get stuck in. So what bike am I using for this build and why did I choose it? So 9 years ago, back in 2010, I undertook a 914-mile, 12-day self-supported cycle adventure from John O'Groats to Land's End. The bike completed it perfectly. It did break down, however, about 500 metres from the beginning of the trip, which to me I was getting a bit worried that this was going to become a big problem, but it proved to be just one little issue. It was a massive trip for me. It was my first bike packing adventure, and it was inspired by Mark Beaumont's trip around the world in 80 days. However, after that, about 8 years went by where it was stored in the attic of my house, and now I've dragged it out, and this is what it looks like. The frame is an extra large 2001 model Klein Attitude. As you can see from the frame, it's finished in Aztec gold with black decals. Back in early 2010 I saw this frame on eBay and it didn't have much interest, with bids around £70, and it was fairly near the finish. I placed a bit of a cheeky bid, so the high bid which I placed was about £80 and I won it for £78. At that point it was a massive shock to me, and I was obviously really happy with the result. I'm not quite sure why the bidding wasn't that high. If I remember right, I don't think it ended at a good time of day, but also it was gold, and back then gold wasn't a particularly great colour. Nobody really wanted it, and the fact, like I've already said, it's an extra large frame. All the parts I then used for building up this bike came from another Klein Attitude I bought really cheap on eBay, and the problem with that one was the frame was badly damaged. So my first concern, as I did not have access to a 650B wheel set, I needed to measure the frame to check the required wheeled clearances. I put a 700C wheel set without tyres onto the frame and took a set of measurements. A friend also did the same with his 650B specific bike, and we compared measurements. The Klein actually had more clearance than his 650B frame, so it looks like it could be a good candidate for conversion. So before we start this build, let's learn a little bit more about what actually happened to Klein bikes. With this, our summary of their history. In 1973, Klein was attending the Massachusetts Institute of Technology, where he and other fellow students looked at how best to design aluminium bicycle frames. At this time, the widespread standard frame construction material was steel, and it had a great reputation. The group of students were interested in how best to design frames that would equal, if not better, the strength and rigidity of those made of steel, and by doing that, they also hoped to reduce the weight of the frame. By examining steel frames that had broken while in use, they were able to determine the stresses placed upon bicycle frames and consider that in their own frame design. Klein's aluminium grade for frame building was 6061. 6061 set a standard for having a medium to high strength. It was lightweight and also an economical material to construct frames from. 6061's other properties include that it had a good surface finish, good corrosion resistance to atmosphere and seawater. It had great machinability, and importantly, it was easy to weld and join. After graduating from MIT in 1975 with a chemical engineering degree, Klein undertook a business course for entrepreneurs. With his knowledge, keen interest in road cycling, and 3 other people, he set about producing a limited run of aluminium bicycle frames. This was undertaken at MIT with a $20,000 grant from MIT itself. The 3 other people with Gary Klein also invested $1,000 each. These early Klein bikes started to show the physical features that became famous later in Klein's existence. The prototypes were displayed at the International Cycle Show in New York in February 1975. In 1976, Klein had relocated to some disused farm buildings on his family property. In 1977, he patented the use of the larger diameter aluminium tubing to increase stiffness. 3 years later, in 1980, Klein moved once again to Chehalis in Washington. At this point, he was able to start production runs of road bike frames, followed by mountain bike frames in the mid-1980s. It was recognised that the use of aluminium alloys to build bicycle frames was not new. However, using the larger diameter tubing to increase stiffness and reduce weight was. This was a real engineering benefit to a cyclist wanting to have the competitive edge. It was estimated that a Klein would have about 15% weight saving when compared with the same level Trek bike in 1995. Kleins were famous for their paintwork and engineering tolerances that ensured that the bike not only looked good but rode extremely well. Welded aluminium needed to be heat treated to restore strength lost in welding. After the treatment, frames were required to be aligned to within 0.004 inches on all aligned surfaces. The manipulated chainstays on mountain bikes allowed a tighter rear triangle to accommodate large off-road tyres and facilitated efficient transfer of power. Another notable feature included the Mission Control or MC1 mountain bike handlebars. These bars were a one-piece unit where the bars and stem were together welded. This helped reduce weight by eliminating unnecessary materials. Klein also held a patent for the improved method of routing cables through the frame of the bicycle. Today we know this as internal cable routing. This reduced the aerodynamic drag and stress on the frame. The front and rear derailleur cables were routed through the down tube and the rear brake cable through the top tube. In 1995, Trek bought Klein bikes, after Klein found it hard to compete without the sales network of a larger company in place. At its peak, around 250 people worked at the Klein Bikes plant, but operation moved to the main Trek factory in Wisconsin. In 2001, a workforce of around 70 people produced 15 to 20,000 frames a year. In the 2002 model year, Klein replaced the 6061 aluminium alloy with a new alloy called ZR9000. This used zirconium in place of chromium. Advertised improvements include a 190-gram decrease in weight per frame and a fatigue life 5 times longer than that of the 2001 model year frames. In 2002, all production moved to the Trek headquarters in Wisconsin. Bikes were still sold under the Klein name until around 2009 in Japan, but widespread distribution ceased in the United States in 2007. Nowadays, the Kleins produced prior to Trek's takeover in 1995 are considered the most desired by collectors and mountain bike enthusiasts. The second-hand market for Kleins nowadays is strong. However, there is a big difference in value between the Kleins produced under Trek and the Kleins from earlier days. So that's our summary of Klein's history. It's not complete. Please take the time to go and have a look a little bit more in depth, undertaking your own searches on the internet. Some really interesting parts of the Klein's history that we may not have had time to cover this time round. However, next is all to do with the build of the bike itself, and we're going to start by looking at the parts we need. Okay, where possible, I've used parts I already had laying around, things that probably would work okay, but have not really had a use for a while. Either that, or I've decided to sort of steal them from another bike for a little bit in my garage, and if they work well, then we'll go and I don't know, maybe buy the same thing or something similar. But the first thing which I'll just speak about is the Ultegra crank. I've had a few of these. I tend to run them on most of my bikes, to be honest. Really good, really reliable things. Don't wear down too fast. That's a 172.5 crank length, which goes on my power meters, which is partly why I really want to continue using that length, because I've got 2 other power meters that will, they're sort of pedal arm power meters, that will link up nicely with that Holotech 2 system. So I'm going to try this on the bike. Fingers crossed it works and there's no issues. Shouldn't be too much of a problem, but we might encounter something. So we'll try that. That's only a 50-34. Most gravel bikes do have way smaller gearing than that as a top ring anyway, as the 50. They usually go up for sort of 40 or 42, I think, on a double. However, I'm going to see how it goes. I'm not saying I've got strong legs, because I don't think I have got particularly strong legs, but there you go. We'll try that. I do have this Ultegra bottom bracket. It was fitted, never used, so it seems pointless to buy another one, and that's pretty good. But it is a road bottom bracket. Again, I hope that doesn't give us any issues with frame. Not a massive experience with fitting them onto mountain bikes, but or mountain bike frames, so we'll see how they go. It might be a slight issue. We got the TRP Spira C disc brakes, which I'm hoping to use, along with the A to Z adapter, which will be my lifeline if it works. If it doesn't, I'm going to throw it as far as I can see it. We've got our Data Zero seat post. That should work just nicely. Not particularly expensive, but not particularly heavy either. Something to go on with. That was something I bought new. Incidentally, the brakes I bought second hand. The bottom bracket, like I said, already had. If we go on to also now, I've gone for a 105 front derailleur to go with the double. The theory along this is that actually the weight saving is quite minimal between that and an Ultegra, and I've read many times before, if you're going to save a few quid on your drivetrain, quite often the front neck is the bit to save the money on, because they're so simple. You really don't get much from going up a level, to be blatantly honest with you. Incidentally as well, I'll be using 105 shifters, normal drop bar shifters, so shifter and brake combined. So 5800 models, so they should be it's the same level as that anyway. Again, I got those second hand. They were cheap as chips and they should be really good. I had to get a braze on adapter. Annoyingly, the only one I could get was a Dura-Race braze on adapter, but hey, there's the weight saving. I don't know, I'm not too worried. A nuke proof seat clamp, definitely needed one of those. Some nice screw on bar ends for the handlebars. All they'll do is I've tried to get them a nice colour as well. Some Snelly ones that will go in and hold the nice new tape I've got firmly in place. I always have a trouble with these things falling off. They're just the cheap plastic ones, so that's why I tend to go for the better ones. And last and not least, something I'm not particularly familiar with is sort of a clutched rear mech. Being a road rider for the last sort of probably near 10 years now, I've not had a clutched one, and I believe they're fairly new, not really new. But anyway, we're going to give that a go, get used to it, fit it to the bike. It will do the jumping teeth size that I need, so the gearing should be fine with that particular rear mech. I think it's quite nice as well if we can keep the Ultegra stuff together. That's my plan. It may go very badly wrong compared to that, and I might have to scrabble around and start buying more stuff. So let's see what I'm left with in the end. And oh yeah, also I've already got a pair of 3T bars I'll be using and a 3T stem with the shifters already mounted on and cables in, which I've already just done, so it should be quite a quick fit up really. And now onto the wheels and tyre setup that I have chosen for this bike. I purchased a set of 650B Mason Cross Hunt Adventure Sport disc wheels. I already know that size-wise they should fit. We've done the maths and there should be no issues with that whatsoever, but it will be nice to actually put them on and see what they look like, especially when we've got the tyres on. Talking of tyres, we've got two tubeless Wildlife Trial Bike Resolute 42s. They are, like I said, tubeless. It is my first time using tubeless. They were recommended to me by a fellow club member, basically because they've got great puncture resistance. They got really good grip and they don't seem to wear down too quick, so they are quite expensive tyres, so I don't really want them to wear out too fast, especially as there will be parts when I use these on the road as well. Also, they were recommended because they were easy to fit, and actually they were fairly easy to fit, even though it was my first time with no real issues and only using a high pressure track pump. So on those wheels though, we also fitted the discs, which were brand new Shimano XT 160mm RT86 rotors, and they're fitted using the centre lock system. We've got some nice centre lock rings actually with the wheels as well, so I used the ones that were supplied by Hunt. And the cassette we'll be using is an 1134 105 level Shimano road cassette. They've always worked well for me in the past, I've had no issues, but we'll see how this one goes. So next up is installing the bottom bracket. Here we're just measuring the bottom bracket shell width to make sure we know what we're working with, and it is a standard measurement for a mountain bike. We will be installing the Ultegra bottom bracket that you saw in the parts section earlier. Screwing in absolutely fine, no issues with the threads or anything. Remember, this one had been fitted to another bike of mine, but I decided I didn't need it at that point. And we'll just screw this side up now. If you've noticed, I'm using this plastic ring tool by Shimano to fit the road bottom brackets. Usually, if you're using like a mountain bike bottom bracket, you just need the metal tool. The cups are actually larger in diameter on the outside and fit this tool much better. I will in a second be going on to installing the non-drive side, the drive side bottom bracket cup. And what I wanted to mention, it's really important at the moment, I've got a bit of a problem with my work stand. It doesn't allow me to angle it to hold the bike up by a more suitable part of the bike itself. So usually I'd want to use the seat post because that's a nice and hard part of the bike. And if you are to damage the seat post, you can actually end up buying those a lot cheaper than what it would cost for a whole new frame. And hence why it's a good idea to use it in that location and not on the top tube. However, you may see this is on the top tube, but it's very loosely clamped, so there should not be any issue whatsoever. So just putting the crank on, I will say I did install a spacer behind the drive side bottom bracket here. You can just see it in the picture actually. You can just see there's a spacer on that bottom bracket cup there. So it does clear the frame fine if you have that spacer, but it doesn't if you don't. Unfortunately, chainrings do bind on the frame. However, once that's installed, there's not a lot of axle coming through to the other side to install the pedal arm on. And the pedal arm anyway will clear the chain stay of the bike, but it is very close. There's about 1 millimetre there, and I'm pressing it there because it's not done up currently, just to well, it might get even closer than what I think, and it might not really work. So anyway, I want to introduce some of the problems of that here in this crank issues presentation I put together. So let's look at some of the details of a bottom bracket to start off with. They're different sizes depending on what type of bike you actually have. So usually a road bike bottom bracket width is bottom bracket shell width, is 68mm. A mountain bike 73mm. So a downhill mountain bike, again, is a bit larger because it's got a bigger tyre that chainstays have to accommodate, and that's 83mm. And finally, a fat bike, much bigger tyres, chainstays have to be further apart, and a wider bottom bracket, and they're about 100 to 120mm. If you look at the picture of the bottom brackets below, you'll see that the width of the cup is different between a Dior bottom bracket and a 6800, which we are using a 6800. And like I said previously, if we look at the diagram now of the crank being fitted through the bottom bracket cups and through the bottom bracket shell, you'll see that the chainring the big chainring is binding onto the chainstay. That's if we didn't install a spacer behind the bottom bracket cup on the drive side. However, if we then sort of remove it all, which is what I had to do, stick a spacer in behind that bottom bracket cup like that, and then screw the bottom bracket cup back in, then reinstalled the Ultegra crank, you can see clearly that the crank is further away and there's no chain rub on the chains, no chain ring rub onto the chainstay. But the splines, there's not enough splines at the end of the axle going into the pedal arm to really be confident that that is a good fix. We may have to try that though at some point. What I do propose is I'm thinking more and more about swapping this bike over to a 1x11 system. So that would allow us a different chain line, which we'll learn about now, and to get a 40 tooth chain ring slightly more away from the actual chainstay. So what we're looking at is the Ultegra crank had a chain line of 43.5. If I buy a GRX 600 Shimano crank, we're looking at that having chain line of 50.1. That means that the middle, basically the middle line of where the chain would run, just comes out that little bit further and gives the ring more clearance against the chain line. Okay, about 6.6 millimeters there it says, so that's good. So the only problem is though, we may need a spacer on the pedal arm side, which is where we might run into the same problem again, where the pedal arm hasn't really got enough of the axle and the splines on the end of the axle to bind onto, and I do want to fit my power meter, and that was one of the main things. I have a 172.5 power meter. I can get a GRX 600 power meter, sorry, not a GRX crank that will go with my power meter, so it all fit really nicely. So I'm just going to take out this Ultegra crank now and say we can't really use it, and I'm going to go for a 1x11 system and order that crank which we've just spoken about. And that's kind of where I'm going to leave it for now, because I'm going to wait for this crank to come along. If you like what you saw today, please subscribe, and you'll learn more and more about when the next episode will be up and ready for you to watch. But until then, happy cycling, guys, and I shall see you soon. Take care. Bye bye.